One important rule with radicals is that we never leave the denominator of a fraction irrational. In other words, we never leave a problem with a radical in the denominator. So for example, in this problem, if I were to simplify it similar to how I've done previous ones, I might say, okay, well, the top is the square root of 4, that's just 2. The bottom is just the square root of 5. That can't be simplified, so I might think this is my answer. However, this is not allowed. No, no, no. We cannot leave a radical in the denominator of a fraction. That's just not permitted. So what we're going to do instead is something called rationalizing the denominator. I'm going to use some clever mathematics to rewrite this fraction so there's no radical in the denominator, and yet it's still equivalent to the original problem. So the way we're going to do that is we're going to take advantage of two simple ideas. The first idea is that if you multiply, and we've seen this a bunch already, if you multiply a radical by itself, that's the same as that thing squared, and you just get the number, right? So it becomes rational when you multiply a radical by itself. The other thing I'm going to take advantage of is that anytime you multiply something by 1, it doesn't change its value, right? If I multiply 8 times 1, it's still 8. If I multiply the square root of 3 times 1, it's still the square root of 3. You know that. So what I'm going to do is I'm going to multiply this by 1, but in a very clever way. I'm going to multiply the top and bottom of the fraction. I'm going to multiply by the square root of 5, over the square root of 5. This expression here is 1, because the square root of 5, anything divided by itself is 1. So why did I do that? I did that because now if I multiply the fractions, if I multiply across the top, I do 2 times the square root of 5, which can't be simplified. That's just 2 times the square root of 5. And on the bottom, I have the square root of 5 times the square root of 5, which, as we said down here, is simply 5. And now, again, all I did is multiply by 1, but now the expression still has a radical in it, but the denominator is rational. The bottom of the fraction has a rational number in it. So this is considered simplified. Now you may be looking at this and saying, well, this original 2 over rad 5 actually looks simpler than this one does. And honestly, that's kind of true. But for our purposes, mathematicians need a standard way of writing expressions so that if I'm doing a problem and I get this is my answer, and you're doing a problem and you get this is your answer, those two don't really look alike. And so it's helpful to make sure that we have a standard way of simplifying. And so that's why that rule is really there. So the bottom line is we never leave the denominator of a fraction irrational. We never leave a square root in the bottom of a fraction. And so the way we deal with that is by using this method, rationalizing the denominator, where we multiply the top and bottom by whatever that radical was on the denominator because it magically makes it go away. That's all. Thanks.